first things first, if you have your schedules in front of you, you might see that the title of the talk is Javaslang Functional Java Done Right, and this is a lie, basically, because there's been a name change recently, and now the Javaslang now is called Waiver. And let me give you a short the backstory of why that happened. Well, basically, probably as many of you know already, it's kind of like a bad idea to put Java somewhere in your name of any of your product. So basically, when the library was growing bigger and bigger, and they reached a point where Oracle reached out to Daniel Dietrich, and yeah, he had not a lot of time to change the name. So one day, actually, there was a new pack of new fresh stickers shipped, and Daniel used, just applied them to his computer, closed the of the laptop, and noticed, well, this is what he noticed, and this is where the name for the library came from. And it's a nice name for creating a new brand. What's also super nice is that you could recycle old stickers. So if we are recycling stickers, I came up with my own idea and also recycled few stickers, but for some reason no one treated my submission seriously. Okay, so my name is Grzegorz, I work in Poland, and I like programming. So basically, if you want to find me anywhere on the net, you can use this handle for Twitter, GitHub, and any other any embarrassing sites probably. So when it comes to the subject, Java 8 was a very special release. From the one side, because we were waiting quite a long time for this one, and on the other side, there was a big breakthrough, because for last seven editions, the Java was pure OOP and kind of tried to stay away from functional programming, but this time it was supposed to change. There were lambdas coming and functional control structures like streams or optionals. So everyone was super excited about that. Yeah, and actually up to some point, this release was being called functional in some way. But when the release happened, people started noticing that the functionness of the Java 8 is basically lambda expressions, optional streams, completable features, and not that much more. People also started complaining that even very simple operations like performing a map operation on a collection, well, is still quite boilerplate heavy. Well, it's still better than iterative imperative approach from Java 7, but still quite boilerplatey. So people started complaining more and more. They started complaining that Java 8 got only 3 functional control structures. Those were optionals, streams, completable features, but other languages like functional languages or Scala, for example, they have much more tools like this. There is no concept of memoization introduced. Don't worry if you don't know what it means, we'll get to that. There is no lifting on partial functions, no pattern matching still, which is a super powerful concept known from the functional world. No tuples. After so many years, if we want to use a pair or something, we still need to implement it ourselves or use one of few thousand projects on GitHub. For some other reason, optional by design was not made serializable or iterable. Well, the explanation for this, it was revealed during one of the keynotes on DevOps that, well, it was supposed to be like this. Well, it's hard to argue with that, but not super convincing. Another thing is, which was the big pain for me, is that we got new tools, but since Java needs to be backwards compatible, well, we end up with APIs that have mixed approaches. Well, some methods return nulls, some return optionals, and sometimes it's easy to get lost. So because of this holy crusade for backwards compatibility, we ended up with a kind of a mess in some spots. Another thing is, have you ever tried playing with checked exceptions in lambdas? It's not really a very like, it's not a nice experience to have. So it's super cumbersome to deal with checked exceptions, and yeah, very problematic. Another thing is something that people were referring to as type pollution, which is basically, if you have a look at the Java util function package, you will see that we have many different interfaces that represent basically functions or our targets for lambdas. So you will find there something like basic function as representative of general concept of a function. You have predicates, consumers, runnables by predicates, consumers by consumers, unary operators, binary operators, suppliers, and so on and so on. And for many people, and for me at the beginning, it was very confusing because, well, I wasn't asked. If you were browsing through like input params or return types of some functions, you would notice that they ask for binary by predicate, okay? And what does it mean? Well, at some point you get there, but at the beginning it's super confusing, and it could be done in a different way. The other thing is, if you want to have like function that accepts one parameter, it's easy, okay? Because you have a function. If you want to get a function that accepts two parameters, it's by function. Well, actually we don't have more in Java. Java is shipped only with functions that accept max 2 parameters. But if you would like to continue like this, you would have like probably like try function, quad function, queen function. Never mind. But this is where exactly the point where my English breaks down, and it's not that much intuitive to find another classes. Basically, another thing is there's the quite boilerplate thing with like that we don't have those like flat maps APIs in the collection API, but we need to still use this stream thing, which, well, adds quite a lot of boilerplate to very simple operations like mapping a list. Essentially, it should be one function call, but now you need to create a stream, you need to perform a map, and then recollect everything to a list back again. So basically we could continue like this, but for now, let's have a look at this one. As you can see here, I implemented this method in a very like kind of unexpected way. So what we have here is basically, as you can see, we are checking the internal state of the object and the state of this of the input, and we are throwing an exception. Okay, but we didn't inform no one that this exception can be thrown over from there. So it's a surprise, okay, that we weren't ready for, and basically should be considered as one of the possible values that functions can return. Let's say that we went past here, and here we have a list. We are adding here something that comes from the internal state of the whole object again. Well, then we are adding something that comes, from some static context out of somewhere else. Then we are having look at the current moon phase, and if this is full, we are removing something from the list. And you can see that, here can be another exception thrown, and we have no idea about that. When we are looking at the function signature, then we are adding even more stuff to the state, then we are modifying something outside the scope, and then returning the result. So this is a very, bad thing to happen, because it can explode on so many levels. So basically, when we are dealing with, Java programs, in functions, if we have the names, we have name, we have a list of input params, and usually we assume that this is like, those are all inputs that can influence our result. But the reality is that usually we have declared params that obviously influence our results, but we have also many different things that can also be influential. So of course, the internal state of the instance state can somehow influence the result, and same with a global state of your application. And if all those things basically can influence your results, they should be considered an input params, okay? But we rarely think about that. And here's what's becoming quite dangerous, because, well, those are possible inputs, but what do you return? Well, if you modify some internal state, if you modify external state, those become inputs of another functions. So you are changing internal state that mutates instance state that becomes an input param of something else, and it modifies something else, and it becomes problematic, because at some point we end up with some clutter that is very unpredictable and can explode in moments where we don't really expect them to be. Good luck with debugging such code. But in functional programming, we strive for a situation where we basically have that all we see as a list of inputs is the only thing that can influence our outputs, ever, okay? And in such case, first thing we achieve this by building very small blocks that work. And if we have small, trivial blocks of code that work, and we compose them together, we usually end up with something that pretty much ends up working on the first try, well, second, third. But if you compose like very stuff that explodes in a moment where you don't expect it to, well, we usually end up with something that explodes in something even more unexplainable way. So, when it comes to Java 8 and the functional aspect of it, many people started calling Java as a functional language now because lambdas were there. But this couldn't be further from the truth. Functional programming goes much deeper than just having lambdas. Basically, we had lambdas in Java before. Well, we didn't have a nice syntax for it, but we still could like use interfaces and anonymous inner classes as basically a way of passing behavior around. And this is essentially the same as, well, the idea of lambda, which is passing a behavior around. So if you try to Google, it's very hard to find a like nice, concise way of the definition of functional programming. But the one I'd like to point you at is the one that I found on one blog, which is functional programming is about writing pure functions, about removing hidden inputs and outputs as far as we can, so that as much of our code as possible just describes a relationship between inputs and outputs. So this is the thing that we will be focusing on today. So in order to achieve this, we need to keep two things in mind. One, immutability and referential transparency. Immutability is pretty like intuitive, because immutability means that after you create something, you can't mutate it. And naturally, this is the way that you restrict yourself, well, all those movements that you can make by mistake to ruin your code or the functionality of your code. Actually, recently, I heard like two JavaScript developers speaking and making jokes, and I heard that they don't need strict typing because they are mature, and well, we are adults and we don't need this stuff. But from my point of view, it's like, well, there are so many possible mistakes to make. Well, we'll always have bugs in our code, even if they are not obvious, okay? And even if we can restrict like some of them by using strict static typing or immutability, it's worth going for. Maybe it will be slightly harder, but still, I think the results are worth it. So another thing is reversional transparency, which basically means if we have some statement, expression, or function, if we call it with the same set of inputs, it will always produce same results. And the moon phase doesn't matter. There should be no additional like side effects. It should always produce same results. And if we write code like this, it also enables us to do some nice optimizations. Because if we know that the result is always the same, sometimes we can cache it. So there's also some common misconception that functional programming is about total removal of side effects or mutability. but it's not really possible. Even languages like Haskell, they have like special ways where you can actually say, well, this is mutable. So we can't really get rid of it everywhere. But by applying, like using higher abstractions, we can basically not deal directly with problems they cause. And this is what we are trying to strive for. So obviously, we will need some code will be harder to write, a bit harder, maybe not that hard, but the satisfaction of running your code when it compiles and you are almost sure that it will run is very useful. So, we already know that we can, to leverage like functional programming, we don't need lambdas. We had Guava in Java 7 and anonymous inner classes, but it's really hard actually to do this if you don't have the right tools for the job. Well, so if you have a look at the Java Collections API, you will have a lot of methods like add, remove, clear, and if you have a look at the return types, you will see that they never return like a new instance. They either don't return anything, which means that they perform 100% side effects. They might return like some metadata or some booleans to let you know if the operation was successful or not, but it's never the new instance. And this is problematic because if one of the building blocks of the language is designed like this, it makes it super hard to, for example, try to code using immutability. In Guava, and there are some immutable views on collections, and I don't know if you remember what happens if you try to call add remove. If you try to call this, you will get an exception. This is super unhandy to use. So, and for example, you can avoid problems like this. So this is a very classic example of a set. You put a date inside, it's a hash set, so the hash gets calculated and stored inside, and since it's not mutable, we have a situation where we are modifying this date outside of the set, and what happens right now is when you try to, if you query your set and ask, is this date inside? Well, we are losing the identity of the object, as you can see. Well, in this case, it's a date, so there's some philosophy between if you change the date is the same, but if you are using with different objects, you might lose the identity. So this is basically where waiver comes into play. So it provided us with totally new collections API with tuples and a new functional interfaces on steroids. So there are those three basic building blocks of Javaslang. Well, waiver. We have Lambda, which is a base for all functional interfaces. There's also a tuple, which is a base for tuples, and a mighty interface of value that represents functional control structures and even the whole collections API. It's a representation of an immutable value that can't change its value after creation. So, as you can see here, this is a very basic functional interface, and we are defining a simple Lambda expression here. And if you have a look here at the name, you can see this 2 here. It's not a coincidence that this 2 is the same as the number of input parameters here. Okay? So the waiver, when it was built that it should be everything super concise. So whenever you want, and easy. So whenever you want to find, let's say, function, tuple, or anything else that has like 2, 3, or n parameters, it's super easy to find because you don't need to remember words in a foreign language, but you have a number over there. So if you are looking for a function that accepts 8 parameters, it will function 8 and not octa function. Okay, so it's super easy to remember. Other than this, looks pretty like Java 8. But what's fine that we got like for every functional interface we got a like special version of it, which is a checked function, which is interfaces that have the throws clause in the the method that represents the target for a lambda. It's super important because it's super handy, because now whenever you want to define lambda that has some call that throws an checked exception inside, well, it will not ask you to handle it inside the body. So this is super handy. But besides this, you still have few nice things. So if you have those new functional interfaces, you can perform function composition in an easy way. This was also available in Java 8. You can perform lifting. We'll get to that. You can perform carrying and memoization, which is my favorite thing here. So in maths, basically, there are functions that don't have results for like all possible input values. They are called partial functions. And basically, we have the same thing here, because whenever we have a function that throws an exception in some situations, basically it doesn't return a normal result. And those are partial functions. But by lifting them, we can change them to total function, which means that it will never throw an exception, but return something else instead. So here we are returning integers and throwing an exception. But what if we were to change the signature of this function so that it always returns some result? Well, but it doesn't always have a result. So what do we return if we are not sure if we have a result or not? We go for an optional. Well, here it's option. So by performing a function lifting, we changed a partial function in total function by changing the result type into an option. This is obviously a case when we don't really care about an exception, but we care about if we got a result or not. And we can change it using a helper method called lift. Super handy. Another thing is carrying, which is a concept known from functional programming, which changes the representation of the function. So here we have a function. Let's have a look. We have a function 2. Okay, I can look. We have a function 2 that has, well, accepts 2 parameters, and well, by performing carrying, we can change its structure. We can change the return type from integer to another function. So if we apply carrying now, we can change the function 2 into the function 1, and instead of, well, returning the result, we're returning another function. Well, it enables us to do partial application in an easy way. So we don't need to apply all possible, we don't need to apply all input params at the same time. We can start applying them one by one. So this is super handy, well, if you have some generic functions and want to, for example, just fix some of those parameters. Unfortunately, you can't pick the parameter that you want to fix. You go only from left to right, but still, we had some very nice, in practice, it was very useful when we were actually doing system that was recognizing documents from photos. So now, after you perform carrying, you call the function again, and here we change the original function that was a sum of 2 integers. We change the function basically that adds 2 to another number, okay, by fixing one of the parameters to 2. And here comes my favorite thing. Remember I was talking about referential transparency? If we know that regardless of the moon phase, and anything else, that function will always return the same result for given parameters, why not cache those results? So this is what memoization does. So whenever we end up with calling the function with the same parameters, it will return our results from a cache. So it's very useful for some internal optimizations. And in Javaslang, it's super easy to create like those memorized functions. There's only like a memorized instance method that needs to be called, and it returns the implementation that caches internally the results of this function. And we can see it in action. Well, actually, it's very easy to see that it works on a very bad example, because now here I'm creating a function from a math random, which is something totally opposite to something that we would call referential transparent. It's totally the opposite, okay? Because when we call math random, we expect it to actually return something else each time we call it. So let's break it. So here we are creating a new function from mathRandom, memorizing it, well, applying it twice, and as we can see, we are getting the same result always and always. Because after the first value gets calculated, it gets stored in a cache, and then just being returned from the cache over and over again. So we are reaching tuples now. So tuple is basically a concept of something that can be thought of like a anonymous object. Sometimes we have situations in our code that, well, especially in Java, do not deserve their own objects, okay? Especially in Java, because you can only define like fields, but you need to define two strings, hash codes, equals, getters, setters, and some other annotations up onto it. So, for example, there are situations where you just want to return a pair and don't worry about that. So this is a way to achieve it. Of course, it's immutable, and as you can see by design, you have a tuple 2 over there. So whenever, if you want to have like up to 8 parameters, you just change the number over there. What's also super nice is that it's typed. So it's not like you're just throwing random Java objects inside, but you still have types over there. And it's super easy. So you have the auth method for creating it, and then you can leverage map, flat map, and other stuff like this for applying some internal transformations to it. Well, when you have a map code, it will always return you another tuple, but there's also an option like there is also a transform method that will allow you to convert it not to another tuple, but to another object. Basically now here you are specifying just achieving whatever you want from the contents of the tuple. Well, if you browse the API, you will see some other very interesting method. For example, to sequence. Well, I've been never able to use that in practice, but well, it's there. So now, the most important part, the value. So if you have a look at the subclasses of this interface, that you have an option, which is basically, well, the optional that, as we know from Java 8, but on steroids. There's a try, which is something similar to an optional, but instead of optionality or nullability, we are dealing with things that throw exceptions at us. We'll get to that. We have a lazy that allows us to do define lazily evaluated variables easily. We have either, which can store like two different types in itself. So it's nice if you have like if you have a method that can result in like, for example, two parallel business logics being fired. So we can use that. There's also a feature, a validation monad with applicative functor that allows us to perform like validations easily. And what's super interesting is that if you have a look at the interface itself, you will see that it extends iterable. So the nice thing you see over there that this is where this is the common denominator between the standard Java classes and waiver, but it's also it can be confusing because you have option try and well iterables. Well, when you think about iterables, it's something that well you can iterate over. You think something more like a collection. Well, but if you think a bit longer about options tries, those are still some kind of containers that hold something or not. So you still can think of it as an iterable that can have max one element. And this can be pretty handy in some situations. Another thing, the whole collections API is a value too. So it represents everything that's immutable and it extends iterable. So this is how we achieve interoperability with Java. There are also new things coming for this, but well, it's not released yet. We'll tell you later. So option, you probably know how to use it already because it works just like in Java, but it's serializable and iterable. So here you're creating an option of something that can be nullable or not. Then you use map calls to like declare your will. What do you want to do with this value if it actually exists inside? And in the last line, you can specify what to do, well, in case if it's not. So it's a very nice and concise way of dealing with nullability without any null checks. And now, have you ever tried, well, have you ever been in a situation where you have a list of optionals and try to like extract only those values that are present from optionals? Well, in Java it's doable. It's not that hard actually if you leverage streams. So here you basically need to do like, you need to create a stream, then you need to filter out all optionals that are in present, then unwrap them manually from this, and then recollect to list. But now we know that, well, options in waiver are basically iterables too. So, and what do we do if we have one collection that holds another collections and we want to flatten it? In such a situation, we would leverage a flatmap API. So here, basically, if you want to flatten something like this and extract elements that exist, it's basically just a one line, because you can feed the flatmap with the with optionals that are in this case treated as collections. So empty optionals are collapsed to nothing, and optionals that have something inside are collapsed to basically those elements that are inside. Also super handy. And by the way, at some conference, someone pointed out to me that this looks like an owl. So, well, I can't unsee it right now. So let's see it try. Try, as I told you, is something very similar in the concept to optional, has the very similar API, but now we can deal with exceptions. So let's create an URI, because we know that they throw a lot of different exceptions. And at this point, you can pretty much forget about try-catching stuff and focus on what needs to be done. So you have this map call where you express your will that we want to get scheme from the URI. And if this is possible, we are getting this. But if it's not, we have a get or else call, which signifies basically a default value that will be returned in this case. Of course, the whole API is much more rich, but it's up for you to explore it. What's really nice that all those monadic-like features, well, they all have same API. They have map, flat map, filter, that you probably all know, but, well, that would be pretty boring. But still you have some very specific methods for each of them. So for example, here you have something like recover, which allows you to recover from some type of exceptions if you know how to deal with them. Another nice thing is lazy. Actually, we could do this in Java 8. In Java 8, whenever you wanted to have like a lazily computed value, you would use a supplier. You would, instead of defining a variable, you would define a variable that would return the result. So obviously it worked, because if you call a supplier, it would be calculated on the spot and not eagerly, but there was a problem with it. If you keep calling it, the result will be calculated each time. So it's not perfect. But with lazy, you can achieve the same thing, but you are caching the results. So it's super nice. And of course, you have the same familiar API. You have maps, flat maps, filter, and so on. So super handy. And as you can see here, we are creating a new lazily computed value by using lazy auth call. And then we are expressing our will that we want to make, that we want to get a string representation of it and then uppercase it. And all of this will be called actually when we reach for this particular value and not eagerly. And now we are going to collections API. The collections API is not it's not new only by design of the API, but in functional programming we are often leveraging something like functional data structures, and essentially those methods are persistent collections. Persistent doesn't mean anything. It's not like you store those on databases or something, because I've seen people like voting on some surveys on the internet like this. But when you think persistence, it means that the collections somehow preserve the previous versions of themselves. And this is super important in the context of immutability. Because if you implement immutable collections naively, what will happen? Imagine a situation you have an empty collection and you want to add a million elements to it. Well, if you keep adding them one by one, well, you of course need to create a copy, add another one, create a copy, add another one, and you end up with a lot of garbage. So this is not ideal, and persistent collections is the answer for this, to minimize the overhead. So instead of just copying and adding and copying, you can pretty much create a recursive structures that reuse already existing parts of collections. It might sound confusing, it's not very, very obvious on the beginning. If you want to learn more about that, there is a great talk by Oleg Shilayev from Zero Turnaround. He was giving this talk in Vox Days Zurich and Devox Poland and Java One, I think, last year. Definitely check this one. It's like 1 hour talk where he goes into deep what persistent collections give you and how to implement them by yourself. It's super interesting because you need to totally rethink your ways you can do some stuff. So let's have a look now at one particular fragment of the type hierarchy in Waiver. As you can see here, you can see many similar names. You can see an array, vector, stack, list, queue, stream. But the question here is, which one doesn't really fit here from the perspective of Java 8 users? Well, if you go over there, you will see that those are all collections, right? But here you have a stream. And in Java 8, stream is not really a collection, but rather a fancy iterator with a nice API. But here, stream is a normal collection without any deficiencies. Well, we know about deficiencies known from the Java 8. In Java 8, for example, we know that streams are non-reusable. If you create them, you have only one time to use them. If you collect them and try to use them again, boom. So here it's nice because it's not a problem. So what's another nice thing is that if you go to the API, you will see that it's super rich. At the beginning, Java 8 API was very overwhelming for me. But at some point, we ended up with a situation. Well, we started noticing that there are some deficiencies. But here, well, it's overwhelming again. And if you ever find something, well, if you don't find anything you're looking for, you can always write on GitHub, start an issue, and it will get implemented, or guys will just explain you in a very polite way why it won't be implemented. So another thing is, well, with this new API, you can, well, impress your friends with building stuff like this. This is a Fibonacci sequence implemented in a purely functional way. Don't ask me to explain that one. Okay, so another nice thing that's introduced in Waiver is pattern matching. This is basically, well, it's not implemented in a perfect way because, well, you don't have any language support to do that. So there needed to be some, well, hacks done to make it work. Basically, pattern matching is like a very advanced version of switch case, where you can basically match everything against everything and decompose objects during this. So in Javaslang, you can achieve this using match API, which looks like this. Should look super similar because, well, instead of a switch, you have a match. You put a value inside, and then you specify different cases that, well, this can fall into. So here you have, as you can see, even numbers, odd numbers, well, and just this guard here, just in case if we end up with numbers that are not odd and even. Well, obviously, there are situations where we know that all patterns are exhaustive, so obviously we don't need to specify all of them, just like here. Obviously, we are not limited to using predicates in cases, so you can perform pattern matching against the whole values. So here, for example, you put some value inside, but you can match it against the whole number 1, number 2. Well, again, specify wildcard using this well, this thing, I know it might be confusing, but this is just a static method that returns something that signifies a wildcard. Another thing is, what's super handy is that you can perform pattern matching against decomposed structures. So previously we're basically matching against the whole values, but here you can perform matching against just the parts of the whole object. Unfortunately, well, it's not like you can just take an object and start using it with pattern matching on the spot. You need to prepare it in a special way so that you can use it like this. Well, but it's not that difficult. The one problem here is that you can't do this recursively, like in functional languages. The problem is that actually guys implemented it like they. The original idea was recursive, but those are all basically a static methods somewhere, and they need to be generated for all possible scenarios. But if you want to generate them recursively, the guys ended up in situations where they were like breaching all possible JVM limits in terms of like the number of methods in a class. So unfortunately, it works on only one level. You can, of course, not only use predicates, values, and decomposed structures. You can use types over there, assuming you prepared your classes correctly, or you can use predefined patterns. And Waiver provides predefined patterns for their classes. Obviously, if you want to play with predicates, you don't need to re-implement the wheel every time. So there's a class that has all those handy predicates for use. So super handy. Here you can hear it, for example, how it could look like in practice. So, for example, this is pattern matching of command line input parameters, and so first case, if the parameter is -h or minus help, you run this, and it's -v version, run this. If not, just don't do anything. What's super handy is that you don't need to use pattern matching as a standalone. It plays really nice. It fits really nice with the existing APIs. So whenever you have option, lazy, try, or other tools like this, you can leverage easily pattern matching here. For example, by like specifying different cases where how you can like process the input param for map or flat map methods. So also super handy. So that will be all. Pattern waiver is not only like the core we've been talking about, but you have also experimental modules like JWT, property testing framework, and some rendering stuff. There's also another side project that provides JSON modules for serializers and deserializers for waiver. So if you ever want to deserialize them, you can use that one. And that would be all. Thank you very much. I'm afraid we don't have much time for questions because of the technical. We have. So thank you very much. And if you and if you have questions, I will try to answer them by not looking at the screen and standing far away from it.
Hi.
Hi.
We're starting to use Javaslang or Waiver. Some problems we're facing is how the collections framework is living with collections from Java, because our code is stuffed between a database and we are providing endpoints. So we are having to convert Java collections to Waiver collections, and then do the same in the other way around. So sometimes it feels like it's not worth it, but we're still evaluating. And I want to know your experiences or your opinions about that.
Yeah, we had similar situations before. I was building an application, well, a classic Spring Boot application with JPA, and this is the place where we actually abandoned. We decided to not use collections API from Waiver because the overhead was basically too big. Because the streams API was enough for our use cases, and It was really hard to justify, well, like repackaging everything just to leverage, well, few API calls that we would use in just a few spots. But there's well, since that time something changed. So Spring Data, for example, now can handle internally some waiver classes. And what's also super nice, the thing I mentioned is that guys are working on a Java interoperability in a very, very nice way. Because so far we had those like 2 Java methods that would just simply repackage waiver classes into collections API. But now they're working on a special views implementations for Java. So instead of like repackaging everything, they will be returning a new implementations that delegate like Java collections API calls to underlying Javaslang collections. And so for now, I think in the waiver 090, there's only available for a list, but there are new ones to come. And this is like super handy because you can, well, there's no repackaging. Well, there will be still some repackaging, but there's not repackaging. It happens in constant time, so it's a little bit easier. I hope it helps. Okay, so thank you very much.